Welcome to the deep dive.
Hello.
This is where we take that stack of sources, you've got articles, research, maybe your own notes, and we really plunge in.
Yeah, we try to pull out the most important bits, the key insights.
Our mission is pretty straightforward: get you well informed on a topic, quickly, deeply, and, maybe uncover a few surprising things along the way.
Think of it like getting the signal from the noise. We go through the details, connect the dots for you, hopefully help you see that bigger picture.
And maybe find those aha moments that make complex stuff click.
Exactly. Make it understandable, engaging.
So today we are tackling, well, it's one of the absolute fundamental shifts in human history, really huge.
It really is.
We're diving into that transition from hunting and gathering, moving with the seasons, following herds, to settling down, planting crops, managing animals.
This whole thing we call the Neolithic Revolution.
Right. And it wasn't just about food or where people lived. It completely reshaped societies, our entire relationship with the environment. It really paved the way for everything that followed.
And we're not just looking at what it was, but, and this is crucial, how it actually spread.
Yeah. How did farming and herding move from those places where they first popped up to transform lives thousands of miles away?
Our sources give us some really interesting angles on this, especially looking at studies that compare the speed and the mechanics of how it spread in different places.
We've got material that takes us right back to the earliest centers of agriculture. We'll touch on the classic theories about how cultural stuff spreads, diffusion theory. And then we'll really dig into a fascinating comparison: how farming spread in Europe versus how herding spread down in southern Africa. Big differences there.
Yeah, that comparison is quite revealing. We'll also look at specific things moving, like, rice, or technologies along routes like the Silk Road.
And then wrap up by thinking about the consequences, why this still matters.
So just try and picture that world again for a second. Small groups of people, moving around, totally tuned into their environment.
Constantly figuring out where the next meal is coming from.
Then, really slowly, almost tentatively at first, people start experimenting, managing plants, dealing with animals differently.
Saving seeds from the plants they liked best, maybe noticing which animals were less skittish.
And gradually, over hundreds, then thousands of years, this whole new way of life starts to take root. Planting, tending, breeding, staying put more.
It wasn't just finding a new food source, it was a revolution.
Yeah.
Completely changed the human story. Let's unpack that journey.
Okay, where should we start? Defining the revolution itself.
Yeah, let's pin down what we mean by Neolithic Revolution. It covers a lot of ground.
It really does. Fundamentally, it's that shift from societies getting food by hunting wild animals and gathering wild plants
The hunter-gatherer lifestyle?
to societies that produce their own food through planned cultivation of crops, that's the farming part, and managing domesticated livestock, the herding part.
And crucially, it wasn't like flipping a switch.
Right.
No.
Not at all. It's vital to see it as a long, drawn-out process.
Yeah.
It unfolded over millennia, not overnight.
So when are we talking about, when did this process really kick off and where?
The earliest signals, the very first stirrings, seem to be around 12,000 BCE.
Wow, that's far back.
Yeah, right after the last major ice age started to wind down. And the location, the Levantine region of Southwest Asia.
What we often call a Fertile Crescent.
Exactly. That arc of land from the Persian Gulf up through Mesopotamia, down the eastern Mediterranean coast. It was just naturally rich in the wild ancestors of key crops like wheat and barley, and also animals that could be domesticated.
So that's the earliest spark. But the solid evidence for plants and animals being truly domesticated, changed by humans, that comes a bit later.
That's right. I mean, people were definitely interacting with wild grains way earlier. We've got evidence for using wild cereals maybe 20,000 years ago, perhaps even early attempts at cultivation around 10,000 BCE. But the really solid evidence for domesticated wheat, where the plant has actually changed genetically to be more useful for us.
Like it doesn't drop its seeds so easily.
Exactly. That's a classic one, the non-shattering rate. It makes harvesting way more efficient. That kind of evidence appears around 9500 BCE, right there in the Fertile Crescent.
So humans are actively selecting traits, changing the plants over time.
It's a partnership, really. Co-evolution between humans, plants, and animals, too.
And the animals followed soon after.
They did. Evidence for cattle herding starts showing up around 8000 BCE. By 7000 BCE, you've got barley cultivation alongside more widespread animal domestication.
Okay.
And we find actual domesticated cattle bones dating to about 6500 BCE in places like Turkey and the Near East.
Were cattle the first animals on the scene, domestically speaking?
Actually, no. Several others were domesticated earlier in that region: sheep, goats, pigs. They were really key early domesticates in the Fertile Crescent.
Right.
And dogs, of course, were domesticated way, way earlier, maybe 15,000 years ago, probably over in East Asia. They were partners long before farming really took hold. Companions, guards, hunting buddies.
So, the Fertile Crescent is the earliest center we know of. But a really key point from the sources is that this wasn't the only place it happened.
Absolutely crucial point. This was a global phenomenon. It had multiple independent origins. Agriculture wasn't just invented once and then copied everywhere.
It sprang up separately in different regions?
Yes, adapting to whatever local plants and animals were available in those areas. Different environments, different solutions.
Okay, let's quickly run through some of those other major centers beyond West Asia.
Sure. So we have West Asia, the Fertile Crescent, with its wheat, barley, lentils, sheep, goats, cattle, pigs. Then heading east, you've got East Asia, another huge center.
Rice and millet country.
Primarily, yes. Rice and millet domesticated there by around 8,000 BCE. Also things like soybeans, azuki beans. And the story of how rice spread from there is massive. It traveled so far.
And rice popped up elsewhere too.
Well, wild rice was around in places like India very early on. Cultivated rice appears later in the Indus Valley, showing maybe deep local history, but also later connections. And we see rice and millet cultivation also appearing, seemingly independently, in parts of Africa and maybe New Guinea around 5,000 BCE. It's complex.
And Africa itself had its own distinct domestications, right?
Definitely. The Sahel region, just south of the Sahara, saw local crops like African rice and sorghum domesticated by 5,000 BCE.
Different from the Asian rice.
Yes, a separate species. And further west, in West Africa, people independently domesticated yams, oil palm, kola nut, another type of African rice.
Fascinating.
And what's really interesting is how plants from elsewhere, like bananas and plantains from Southeast Asia or New Guinea, seem to have been sort of re-domesticated or adapted in Africa maybe 5,000 years ago. The Ethiopian highlands are another unique spot: coffee, khat, teff, and saita, very distinct crops.
Okay, crossing the ocean to the Americas. They didn't use the term Neolithic, but the same basic shift happened there too.
It absolutely did. Mesoamerica, Mexico, Central America was incredibly important. Squash domestication there goes back maybe 6,000 BCE, beans around 4,000 BCE, and maize, or corn, started its long journey from a wild grass called teosinte around 7,000 BCE.
The three sisters, maize, beans, squash.
A foundational complex for many cultures there.
Oh.
Then in South America, potatoes and manioc were the big ones.
Yeah.
And up in what's now the eastern United States, people independently domesticated plants like sunflowers and goosefoot around 2,500 BCE.
And one more key spot, New Guinea.
Right, shouldn't forget New Guinea. The Cook Swamp site there has evidence for taro cultivation, possibly going back 11,000 years.
Whoa, that could be among the earliest cultivated crops anywhere.
Potentially, yeah. And maybe utilized even earlier in the Solomon Islands nearby. Bananas and sugarcane also show up early at Cook Swamp, around 7,000, 6,500 BCE. It just shows the incredible diversity of pathways into food production.
So multiple independent starting points, but like you said, invention is only half the story. It's also about the spread. And it's important to remember, as the sources point out, that the shift wasn't always to the full package deal, settled farming and keeping animals.
That's a really critical distinction. Sometimes, especially in areas maybe less suited for intensive crop growing, the primary shift was towards herding, pastoralism.
Focusing mainly on livestock.
Yeah, managing herds, often still being quite mobile, maybe doing some hunting and gathering or fishing on the side. And southern Africa, which we'll get into, is a prime example. Herding spread there widely without settled farming or even metal tools initially.
Okay, so that difference, the full package versus primarily herding, that really sets us up to understand how this revolution spread, which brings us to diffusion.
Spot on. Independent invention explains the origins, but diffusion helps explain how these new life ways and the plants and animals themselves traveled from those origins to transform huge areas that didn't invent them independently.
And the classic framework for understanding this spread is diffusion theory.
Yes, classical diffusion theory was a big idea. It basically proposed that cultural traits could be anything: a tool, an idea, a farming technique, a religious belief, originate in specific centers, and then spread outwards from there.
Through contact between groups.
Through contact, borrowing, adaptation. It was a counter-argument to the idea that every society just marches through the same evolutionary stages on its own. It emphasized connection and influence.
So what are the nuts and bolts? How does the spread actually happen according to the theory?
Well, they identified a few main mechanisms: The most straightforward is probably direct diffusion.
Sounds like what it is direct contact.
Pretty much. It happens between cultures that are neighbors, geographically close, interacting regularly. Think trade, intermarriage, maybe just seeing what the folks next door are doing and copying it. The slow village-to-village spread of farming methods is a good example.
Okay. Then there's forced diffusion.
This one's less about friendly borrowing and more about power dynamics. It's when one culture imposes its traits on another, usually through things like conquest or colonization.
So the winners forcing their ways on the losers, basically.
In many cases, yes. Think about the spread of European languages or Roman law across conquered territories. That wasn't voluntary adoption for the most part.
Right. And the third type, indirect diffusion. That sounds like it could cover more distance.
It often does. Indirect diffusion involves intermediaries.
Yeah.
Cultures don't have to be in direct contact to influence each other. Things can spread along trade routes through third parties.
Like a game of telephone almost.
Kind of, but maybe more structured. The sources mention Buddhism spreading from India across Asia. It didn't just jump to China or Japan. It traveled along trade networks, like the Silk Road, carried by merchants, monks, travelers in Central Asia, getting interpreted and adapted along the way.
The Silk Road seems like the perfect example of indirect diffusion in action. Goods, ideas, technologies all moving together.
Absolutely. Papermaking is another great example mentioned. Invented in China, it moves west along the Silk Road, hits Central Asia around the 8th century CE, then the Islamic world, finally gets to Europe centuries later, around the 12th century.
And it wasn't just the same technique being passed along unchanged.
No, definitely not. At each stage, people studied it, figured it out, often adapted it using local materials or improved it. It shows diffusion isn't just passive copying. It's an active process of taking something, understanding it, and making it your own, transforming it.
So thinking about the Neolithic package, farming, herding, all those plants and animals traveling thousands of miles across continents, which of these diffusion mechanisms do you think was most important? Was it mostly neighbors, copying neighbors? Was it conquest? Or was it that slower indirect spread along interaction networks?
That is the million-dollar question, isn't it? And it really leads us into some of the most interesting research, which tries to actually measure this spread and finds, maybe unsurprisingly, that it wasn't the same everywhere. The mechanisms, the speeds, they varied.
Which brings us squarely to that comparison, Europe versus Southern Africa. This is where researchers have actually tried to quantify the speed of the spread.
Exactly. It's been a long-standing question. Is there a universal rate or mechanism for how the Neolithic spreads? Or does it depend? Depend on the place, the people already there. What exactly is spreading farming versus just herding, for instance?
Let's start with Europe. The European Neolithic spread is probably the classic case study.
It's certainly the most studied. Researchers have used radiocarbon dates from thousands of early farming sites across Europe. By plotting these dates geographically, they can track the expansion.
And calculate how fast that farming frontier moved?
Precisely. And what they found was, well, remarkably consistent. The spread rate averaged out at about 1 kilometer per year, maybe slightly more, 0.9 to 1.2 kilometer, depending on the exact methods and calibrations used, but very much in that ballpark.
Okay, so picture that. A slow, steady wave moving across Europe, roughly a kilometer deeper each year, for thousands of years.
That's the image. And based on that relatively slow, steady pace, the dominant interpretation, the main model, has been demic diffusion.
Meaning it was mostly the farmers themselves moving.
Yes. The idea is that the spread was primarily driven by the actual migration and population growth of farming communities expanding into new territories. Existing hunter-gatherers might have been absorbed, pushed out, or maybe adopted farming later, but the main engine was the movement of people. Cultural diffusion, locals adopting the new ways without lots of new people arriving, was seen as playing a secondary role in Europe.
Okay, so that's the European picture, about 1 kilome a year, mainly driven by migrating farmers. But it looks very different when we turn to Southern Africa.
Very different indeed. The study highlighted in our sources applied similar methods, looking at the dates of the earliest sites with domestic animals, specifically sheep, goats, and cattle, across Southern Africa.
Where did these animals first appear in that region?
The oldest sites are generally found in the northwest, places like Leopard Cave in Namibia, with dates around 280 BC, so much later than the start in the Near East or Europe.
And the speed. How fast did herding spread south from there compared to farming in Europe?
It's significantly faster. The calculations showed a spread rate averaging around 2.4 kilometers per year, with a likely range between 1.4 and 3.3 kilometers.
Wow, okay. That's easily double the speed we saw in Europe. Why is that speed difference so critical?
It's critical because of how the models work. Those wave of advanced models used to analyze these spreads suggest that speeds substantially faster than that 1 kilometer benchmark point towards a different primary driving force.
Not demic diffusion.
Not primarily demic diffusion. Rates like those seen in southern Africa strongly suggest that cultural diffusion was the dominant mechanism.
Meaning it wasn't mainly groups of herders migrating south.
The interpretation is that it was largely existing hunter-gatherer populations adopting herding practices. They learned it from neighbors, maybe from small groups of herders they encountered, rather than being replaced by incoming populations.
So the ideas and the animals spread faster than the people who might have originally brought them.
That's the essence of it. The spread was fueled by local adoption, by hunter-gatherers becoming herders. The study even tried to model this, looking at how many hunter-gatherers might be converted to herding per herder per generation, based on some historical analogies.
And did the model match the observed speed?
Remarkably well, the predicted speed range based on plausible rates of cultural transmission lined up very nicely with the actual archaeological speed calculated for southern Africa. It's strong support for cultural diffusion being the main driver there.
That's fascinating. So why the difference? Why cultural diffusion in southern Africa, endemic diffusion in Europe?
Well, the analysis in the study suggests it boils down to what was spreading.
Hmm.
Remember, the European Neolithic involved the whole package: settled life, intensive farming of crops like wheat and barley, plus livestock.
Right, a total lifestyle overhaul.
Exactly. That's a huge shift. It requires different land use, different social organization, building permanent structures. It's arguably much harder for mobile hunter-gatherers to just adopt that whole package culturally on a massive scale.
Okay, whereas herding.
Herding, especially the kind that spread initially in southern Africa, involved managing mobile animals. While still a major change, it might have been, more compatible with existing mobile lifestyles. Easier to integrate or adopt, perhaps initially alongside continued hunting and gathering, without demanding an immediate total shift to settled village life and intensive planting.
So maybe herding on its own is just more easily transmitted culturally than the full farming package.
That's the core hypothesis put forward. The specific package being adopted shapes the mechanism and speed of its spread. The study also noted the spread in southern Africa wasn't just random. It seemed to follow certain routes, maybe down the Atlantic coast, then east, suggesting it moved along existing interaction corridors or favorable landscapes.
This whole comparison really hammers home that the spread of the Neolithic wasn't one single story. It was complex, varied, shaped by local conditions and what was actually being adopted.
Absolutely. It's a great corrective to thinking about it too simplistically.
Now, moving beyond those broad patterns, the sources also give us some specific examples of diffusion, not just in prehistory, but more generally, which kind of bring the concept to life.
Yeah, and they show it's not just about food production techniques moving around. Ideas, beliefs, technologies, they all diffuse.
Religious diffusion is a powerful example.
It really is. Major world religions rarely stayed put. Think about Buddhism starting in India. It didn't just stay there. It spread across Asia.
How does that happen?
Through various means, trade routes were huge, like the Silk Road. Merchants, missionaries carried the ideas. Sometimes rulers adopted it and promoted it. But importantly, as it moved into, say, China or Japan, it wasn't just copied. It was interpreted through local cultural lenses, blended with existing philosophies, leading to distinct forms like Zen Buddhism. It adapted.
And Islam shows a similar pattern, right? Spreading far beyond Arabia.
Absolutely. From the Arabian Peninsula, Islam spread incredibly widely. North Africa, parts of Europe, Central Asia, Southeast Asia, again, through a mix of conquest, trade, migration, missionary activity, and everywhere it went, it interacted with local traditions. Islamic art, law, practices took on distinct regional flavors. That local adaptation is key.
Okay, then there's technological diffusion. We mentioned papermaking already, traveling that long route from China to Europe.
Yeah, and getting adapted at each step, that's a perfect illustration. But think about core agricultural technologies too. The plow. Seems it started in Mesopotamia, maybe 4000 BCE, probably just a modified stick initially.
Yeah.
But the big leap was harnessing animal power, oxen, to pull a heavier version. That allowed people to break up tougher soils they couldn't cultivate before just using muzzle power. That technology spread.
And the seed drill. Planting seeds efficiently in rows.
Also surprisingly ancient. There's an image on a Sumerian seal, 3rd millennium BCE, showing something like a seed drill, way before Jethro Tull often gets credited in Europe. Shows early innovation and presumably diffusion of these fundamental farming tools.
And this drive for agricultural tech didn't stop there, did it?
No way. The whole agricultural system constantly pushed innovation. Irrigation systems became incredibly sophisticated, like in the Indus Valley or ancient Egypt. Tools for harvesting, processing, think early cotton gins in India. Then much later, the scientific understanding figuring out soil chemistry for fertilizers, Mendel's work on genetics leading to selective breeding, all these diffused and built on each other.
So technology and scientific knowledge related to farming kept spreading and evolving.
Constantly. And maybe the most fundamental diffusion in this whole story is the dispersal of the domesticated plants and animals themselves.
Right, the actual biological package moving around. Our sources list quite a few.
Yeah. Wheat and barley from the Fertile Crescent, they go west into Europe, but also east into Central Asia, India, showing up in the Indus Valley by the 6th millennium BC. Rice from East Asia travels across mainland Asia, but also makes incredible sea journeys with migrating peoples like the Austronesians.
Taking it all the way to places like Madagascar.
Exactly, and East Africa, eventually. That's diffusion on a massive scale, carried by people moving.
And maize, corn, from Mesoamerica.
Spreads throughout North and South America. Its arrival in places like the southwestern U.S. completely transformed societies there, enabling larger populations and different settlement patterns. Then you have things like cotton and sugar, cultivated early in the Indus Valley. Sugarcane itself from tropical Southeast Asia, spreading much later globally. Coffee from Ethiopia, moving to Arabia, then the world. Tobacco, potatoes, tomatoes from the Americas going global after 1492. It's a constant exchange.
An incredible global reshuffling of life forms driven by human activity, and the animals move too.
Yep. Those key Near Eastern domestics, sheep, goats, cattle, pigs, they spread into Europe with farming. They also move south into Africa, forming the basis of herding economies there, as we discussed. Horses, domesticated probably on the Eurasian steppes, spread incredibly fast and much later transformed life for plains indigenous groups in North America when they arrived with Europeans.
So diffusion theory seems like a really useful lens for understanding all this movement. But you mentioned earlier it wasn't perfect. It faced criticism.
Right. Like most big theories, especially from the early 20th century, classical diffusion theory had its issues and needed refining.
What were the main criticism?
One big one was oversimplification. Critics felt it sometimes reduced cultural change to just passive borrowing. It didn't always appreciate the agency of the receiving culture, how people actively choose what to adopt, how they adapt it, reinterpret it, maybe even reject it. Diffusion isn't just copying, it's often transformation.
Like we saw with Buddhism or papermaking.
Exactly. Another issue was the neglect of independent invention. Sometimes diffusionists might have been too quick to assume that similarities between distant cultures must be due to diffusion, underestimating the possibility that different people could independently come up with similar solutions to similar problems.
Like inventing the same tool because it's the logical way to do something.
Precisely. Convergent evolution, but in culture. Then there were issues around biases.
How so?
Some early diffusionist thinking, perhaps unintentionally, reflected the biases of the time. It could imply that innovation only flowed from a few advanced centers, often implicitly including Europe or the ancient Near East, to supposedly more primitive peripheries. It sometimes downplayed innovation happening elsewhere.
Kind of a colonial mindset leaking in.
Yeah, some critics argued that. Extreme versions that tried to trace almost all major innovations back to a single source, like Egypt, were pretty thoroughly debunked. And tied to this were methodological weaknesses. Sometimes connections were claimed based on fairly superficial resemblances without strong proof of actual contact or transmission.
Okay, so the classical theory had its blind spots. But the basic idea that cultures influence each other through contact, that's still valid, right?
Oh, absolutely. Modern approaches don't throw out diffusion, they integrate it. They see cultural change as a mix of factors. External influence, diffusion, and internal dynamics, independent invention, local adaptation, social change. It's about understanding the interplay.
And in today's world, diffusion seems like it's on hyperdrive.
Totally. Globalization, the internet, mass media, easy travel ideas, technologies, trends, music, fashion, even diseases, they can spread globally incredibly fast. Understanding diffusion dynamics is more relevant than ever, whether you're talking public health or viral marketing.
It's not just farming techniques moving at 1 kilometer anymore.
Not even close. And we see that adaptation process happening constantly, too. This idea of globalization, global things getting localized, adapted, creating hybrid forms. Think of global food chains having totally different menus in different countries, or global music styles getting fused with local traditions.
So it's not just homogenization, it's also creating new diversity through mixing.
Exactly. It shows the interaction leads to complexity, not just uniformity.
Hmm.
It requires looking at both the flows between groups and the creativity within them.
And bringing it back to the Neolithic, this whole revolution, its origins, its spread, it had absolutely massive, long-lasting consequences. It changed almost everything.
Fundamentally, the most basic was social change. Moving from small mobile bands to larger settled communities changed everything. Populations could grow, leading eventually towards villages, towns, cities, states.
But it wasn't all positive initially.
Not always. Storing food allowed for surpluses, but relying on just a few staple crops could sometimes lead to nutritional issues compared to a diverse forage diet. And living closer together, often with animals, meant diseases could spread more easily. New social structures emerge, sometimes more hierarchical ones.
And you mentioned the secondary products revolution earlier. That seems like a huge consequence tied to the animals.
It's a really crucial concept. Early on, maybe animals were mostly about meat. But then people realized, hey, these animals offer way more while they're alive.
Milk, wool.
Milk, wool, hides, manure for fertilizer, and crucially, power, traction, using oxen to pull plows, using animals for transport.
So animals became renewable resources, living engines.
Exactly. It wasn't just a walking food source anymore. This massively increased productivity. It allowed people to farm heavier soils, transport goods more easily, develop specialized pastoralism and grasslands. It fundamentally changed the energy available to human societies and deepened our relationship with domestic animals.
And all these new challenges and opportunities spurred technological advancements.
Continuously. Managing crops, processing harvests, storing food, managing water with irrigation, handling animal products. It all drove innovation. From better plows and sickles to pottery for storage to looms for weaving wool.
And later on, the more scientific understanding kicked in.
Right. Understanding soil nutrients led to fertilizers. Understanding heredity, thanks to people like Mendel, allowed for much more effective selective breeding of both plants and animals, boosting yields dramatically, improving things like crop rotation, building on ancient practices but refining them. It's a continuous thread of innovation tied to managing agriculture.
These advancements allowed for bigger populations, more complex societies, but also presumably a much bigger human impact on the planet.
No question. Intensified land use, deforestation, altering landscapes for fields and pastures. The environmental consequences started right back then and have obviously continued to grow.
So wrapping this up, we've traced this incredible journey from multiple independent sparks of farming and herding around the world
To understanding how these revolutionary ways of life spread, through direct contact, sometimes forced, sometimes through indirect networks over vast distances.
we saw how the plants, animals, and technologies themselves moved, reshaping ecosystems and societies far from their origins.
And that key comparison, Europe versus Southern Africa, really highlighted how the process of spread could differ dramatically. Different speeds, different primary mechanisms, endemic versus cultural diffusion, likely tied to exactly what was being adopted.
Yeah, the Neolithic wasn't a monolith. It was complex, adaptable.
We also touched on the critiques of diffusion theory, but how the core idea of interconnectedness and influence remains vital, maybe more so today than ever.
And finally, the profound consequences. Reshape societies, new technologies, the game-changing secondary products from animals, and ultimately a transformed relationship between humanity and the environment.
It really shows how a shift in something as basic as how we get our food can fundamentally rewire, well, everything about human civilization.
It really makes you stop and think, doesn't it? If that ancient shift to agriculture triggered such massive cascading changes over millennia, what kinds of diffusion are happening right now?
You mean like digital tech, AI, genetic engineering?
Exactly, things spreading globally at incredible speed. Could some of these be sowing the seeds for transformations just as profound, just as unpredictable, maybe, as the Neolithic Revolution was? What future revolutions might we be living through the very beginnings of right now?